3 video, polynomials. So we're looking at polynomials meaning many terms. So we have examples like 3x cubed. So here's one example, 3x cubed plus 2x squared minus 6x plus 7. So here we have 4 terms. And this is called our constant, the one without the variable attached to it. And then our largest exponent is called the degree. So this has a degree of 3. If there's more than one variable, so notice how those all have x's in them, except for the 7, that's called our constant. So if we have one that is more than one variable, then we look at each term and look at what is the largest. So this actually is x to the 0. We look at each term and find out how many exponents they have in it, right? So this is 2, this is 1, so really the degree of this term is 3, the degree of this term is 2, the degree of this term is 1 and 0. And so the degree of the whole polynomial is the largest degree of a single term. So this would be degree 3 as well. Okay, so a single term. So I look at all the terms and I add up all the polynomials and see what it is. And whichever one has the largest degree of each term, that is the degree of the entire polynomial. So the entire polynomial is just 3 for this one. Okay, so if you can remember the exponent rules, product rule, right? When we multiply by the same base, we go ahead and add our exponents. So this is 3 and this is 2, then it is m to the 5th, right? Multiplied by the same base, you add exponents. Power rule, if I raise a power to a power, so m to the 3 raised to the 2, that is m 3 times 2, so that's m to the 6th. And then power of a product, so if I'm multiplying in here, so a times b, and I raise that to a power, then I distribute that power to the exponent, so a squared plus b squared. No, did I say plus in there? I didn't mean plus. A squared times b squared. It doesn't do it over addition or subtraction, only a product when it's multiplication here. Then I distribute that 2 to the powers, right? And then lastly, if I have a quotient, so if I divide by the same base, a and a, m and n, then I go ahead and subtract those exponents, okay? Now that last one leads us to the negative exponent rule. It just means that when I have a negative exponent, then I can rewrite that as a positive exponent. I just put it under 1. And so now it's positive. Or I can switch. If I have a negative exponent on bottom, so say I have 1 over a to the negative b on bottom, I can switch that and I can move it to the top like that. Okay, so you can move it up and down, just change the sign of the exponent. 0, anything raised to 0, a to the 0 equals 1, anything raised to 0 equals 1. Quickly, if you have a negative exponent, so say 5/3 raised to the negative 2, then I can just flip that fraction. And now it's a positive exponent of 2. So I can do that. That's what the negative exponent allows me to do. All right, simplifying polynomials. So we can simplify these things. Here we're adding. You got to know the difference, what's in between here. Is there plus sign, is there minus sign, or is there no sign? If there's no sign, then it's multiplication. But here we're adding, but we can only add like terms, so they have to have x to the 4th. So I can only add these two. So that's 6x to the 4th. Then I look at my x squareds. There's 1x squared here, so 7x squared and negative 3x squared is a 4x squared. I have a plain x and I have a plain x, so 1x plus 6x is 7x. Positive 7x, there's adding that polynomial. Okay, on bottom I'm subtracting, so you can do 2 different things. I would just advise distributing that negative to all 3 of these, and then go ahead and just add. That's a common mistake that always happens with subtracting. You're subtracting every single one of these, so that's why it's changing signs. Or you can think about this negative as opposite. Opposite of m cubed is negative m cubed. Opposite of 7m squared is a negative 7m squared. And opposite of negative 3 is a positive 3. Now I can combine like terms. Negative 3 minus an m cubed is a negative 4m cubed. an m squared, and m squared minus 8m squared and minus 7m squared is a negative 15m squared. 4 plus 3 is 7. So there's that simplified. Okay, notice multiplication. There is no sign in between here. So that is multiplication. So make sure you check your signs again. Now, I have 2 terms, 1, 2, and I have 2 terms on this side, so I should have a total of 4 terms. So 3x times 2x is a 6x squared. X times x is x squared. 3x times negative 3, 3x times negative 3 is negative 9x, and 1 times 2x is a 2x. Those have same terms, so I can combine negative 7x. And then 1 times negative 3 is a negative 3. Okay, this has 3 terms. This has 2. 3 times 2 is 3 times 2 is 6. So I should have 6 terms. This one, notice that I did have 4 terms. And then, but I can combine those 2 ones in the middle. So 3 times 2 is 6, so I should have 6 terms. 3x squared times x is a 3x cubed. 3x squared times 1 is a 3x squared. 2x times x is a 2x squared. 2x times 1 is a 2x. I forgot the squared on this, sorry. Squared, 2x. Negative 1 times x is a negative x. And negative 1 times 1 is a negative 1. Now I can combine like terms. So we get 3x cubed. So what is my degree of this polynomial? My degree is 3. That's the degree of the polynomial. Division, okay, division. Oh, synthetic division. Let's just do synthetic division here. So synthetic division, give you a little taste here, and we'll talk about it more, I think, in like chapter 3, something like that. So hopefully I recorded that whole thing. I don't know if I recorded that whole thing. But here's that problem kind of worked out, but we will go through it in a different section. All right, long division, you have to remember, so what we need to do is set this up. If there's any gaps, we need to make sure they're there. So we go x cubed. What's the largest exponent is cubed, so it's a degree of 3. Then we go my degree of 2. We don't have a degree of 1, so we need to leave a space there. So this would be just plain 0x, because 0 times x is 0, and then our constant. And then we're dividing that by x squared minus 4. And then I kind of need some space here, so I'm going to erase this part. Okay, so then we just ask ourselves, what times x squared gives me an x cubed? That's another x. And then I need a 3. How do I get a 3? 3 times 1 is 3. So then I distribute that to both the x squared and the 4. So that's a 3x cubed. You want the same thing here. And then I multiply it by the negative 4. So that's a 3x to the negative 4. A 3x times negative 4, sorry, is a negative 12x. And so notice there's a gap there. So I need to not put that under this one. I need to move that over and put it under this one. Okay, and there's another part that gets confusing here, because I want this to go away, so I need to subtract this. Well, if I subtract this one, then I'll have to distribute that negative, and so that's now going to be a plus. And now I bring everything down. This is 0, this is negative 2x squared, this is now a 12x, and this is a negative 150. And now I ask myself, okay, I need the same thing here. So what times x squared gives me a negative 2x squared? Well, that's a negative 2. And I don't need any x squared, so I just need negative 2. So negative 2 times x squared is negative 2x squared. And then negative 2 times negative 4 is an 8, so I put that over here as 8. Now I go ahead, I need to subtract them now to make this one go away. So this becomes a plus, and I distribute that, and this one becomes a negative. So now when I add these, I get 0. I get 112x, and I get negative 158, sorry. Okay, and so that would be my remainder there. And you're probably confused of why I have 112 here. That was because this was supposed to be an add. So it's just supposed to be 12x. So there's my remainder. So my answer to this is 3x. minus 2 with the remainder of 12x minus 158 all over what I'm divided by x squared minus 4. Alright, so here's an example real quick. So here, divide. I can do synthetic division, so let me do it just in case I didn't get that first video of it. So what's my degree of the top one? Is 3. So I have 3, 2, 1, 0. And I can set this equal to 0. So m is equal to negative 2/3. Synthetic division, I would list my coefficients, and nothing's missing because I got 3, 2, 1, 0. And I am recording this one, so that's good. My m, what's going to go in the box here is negative 2/3. 0 is always going in the first one. Add the columns, multiply the rows. So that's going to cancel. So 2/3, negative 12/4 negative 4. Add those. Get 3, multiply, get negative 2, negative 6. Multiply, get positive 4. Add those, get 6. So this is 6m. Now I drop the power because I'm dividing by a degree of 1. So I'll go 2 plus 3m minus 6, and then with the remainder of 6 over what I'm dividing by 3m plus 2. There you go. All done. Under 12 minutes.